All right, let's look at this example here to understand the greatest integer functions. So hopefully you understand the general idea of how greatest integer functions work. So the idea is that when you plug in a value into the function, whatever's inside the greatest integer function portion, you want to simplify. There may be a little bit of simplifying with like C and D. You'll notice that there's some simplifying that you'll need to do. So it's just regular old math with the simplifying inside there. But once you have the number inside the greatest integer function, you know that you have to round down to the next integer. Um, so if you get like 3.4, you have to round down to 3. So let's just see if we understand how this works. Looking at let's just build a few values in the table. And we're actually going to look at all the functions. T of x, let's just look at that one first. So let's look at 1/2. And if we look at t of 1/2, we have 1 plus 2 1/2. So there's no simplifying involved here in terms of what's inside the greatest integer function. So we just need to apply that greatest integer function to 1/2, which means we're rounding down to 0. So this is 2 times 0. This is 1 plus 2 times 0. And that gives us 1. Okay, so we plug in 1/2 and we get 1 out. So there's one ordered pair we just get from there. So we have enough room to look at. Let's look at, I guess, C. Let's look at C. So f of x. So f of x, we have 1 plus 2x. So that, but that's all inside the greatest integer function. So it's 1 plus 2 times 1/2. So as I mentioned before, you want to simplify what's inside the greatest integer function first before you actually apply the greatest integer function. So this gives us greatest integer function of 1 plus 2 times 1/2, which ends up being just 2. So there's nothing to simplify there. We're at that greatest integer function, or that value that we need, which is 2. So just from right here, I mean, we can already tell that f of x is not an option, because we notice that when you plug in 1/2 into the function here, it's up by 1. And so we have an output of 2 using the f of x function. So we know that f of x is even a possibility. So we can ignore that function. So what would be helpful is to notice a pattern. What is happening here? So we'll notice that if we understand that we round down to the next integer, we'll notice that for rounding down each time, then the only way that we would have a jump, so notice that this is jumping up 2 units right here. That's 2 units. It's jumping up every time. Notice that this difference is, it's always 2. So since the difference is always 2, the way that we end up having this, if you think about how you plug in, like if we were to plug in anything between 0 and 1, not including 1, so anything between 0 and 1, it will always round down to 0 using this function t of x. It will always round down to 0. So, so you have an interval of 1 that will round down to a width of 1 for values you can plug in for x. That will round down to 0. And then notice that it's then after you do the greatest integer function portion, you're multiplying it by 2. So that is what's making it have a distance of 2 in between each of the functions. So notice that if we were to plug in like 1.5 or something, notice that if we were to plug in anything between 1 and 2, not including 2, it'll round down to 1. So we will have 1 plus 2 times 1/2, or sorry, 1.5. So this will round down to 1, oh, I guess I don't need that anymore, times 1, it'll round down to 1. And so notice it goes from 0 to 1. So anything between 0 and 1, if you plug it in for x, it will round down to 0. And in between 1 and 2, not including 2, it'll round down to 1. So it's jumping up 1 every time, just from the greatest integer function. So you need to multiply by 2 on the outside to have this distance of 2 in between. So you'll notice that. Like when we multiply by 2 in this instance, it'll be 1 times 2 plus 1. We'll get a 3 as an output. So anything in between 1 and 2, not including 2, and anything in between 0 and 1, not including 1, you'll have this distance of 2 in between. And that's based off of the 2 multiplying on the outside. And then this plus 1 is the shift, the vertical shift, so that we have the right y-intercept. And we'll notice that, after evaluating a few, and that's the best way of doing it. It's just evaluating a few values in the function to get some inputs and outputs. You'll get some values in your graph, and you just need to make sure that they match up to some values that we see here. And we can tell that the ordered pair 1/2, 1 is in this function, in this graph here. So 1/2, 1, that's located right in there. And then notice that 1.5 and 3, that is located right here. And notice that we're going to have an x value in between 1 and 2, not including 2. It'll always have an output of 3, so that's why it's always, we have this flat portion right here. So notice that little pattern there. Now notice that if you were to plug in some values, other values in for x, the width that we have right here, as you can see, it's always the same width, and that width is 1, and that's based off of plugging in just x. The greatest integer function portion is just the x. So if you start doing like 1 plus 2x, then that width will be changed. You'll notice that because if you're rounding down the value that you're simplifying in the greatest integer function, it will. So let's just look at one more value in this f of x function. Let's look at let's just plug in 1/4. So it would be 1 plus 2 times 1/4 for this f of x function. And we have, this will end up being 1.5, as you'll see. So this will end up being 1. We don't need the bracket. This will round down to 1. So notice that even in the same interval between one, if we're comparing 1/2 and 1/4, they're both in the same interval, between 0 and 1. But notice that they ended up getting a different output. That's because of this 1 plus 2x. When you have other things going on inside this interval, especially multiplication, then your interval is going to, the width of each of these steps is not going to be 1. So multiplying inside of the brackets, or the greatest integer function, will mess with the width of your steps. So anyways, I hope this makes sense. Just in general, approaching these type of problems, you want to build the graph. If you're starting out with the function, greatest integer function, and you have to find the graph, most definitely you want to plug in values into the function. But even if you're going from a graph to a function and trying to figure out what function matches that graph, like this problem, just start plugging values into the function. You can quickly eliminate which one is correct or not. And hopefully you're understanding how greatest integer functions work. You want to simplify everything in between, inside the greatest integer function, before you actually apply the greatest integer function. So as you can see here, I I simplified this down to 1.5, and then I applied the greatest integer function. And if there's anything outside the greatest integer function, like the function t of x, you want to make sure that you again simplify everything within inside, which there really isn't anything, and then you apply the greatest integer function. And then after you do that, you simplify everything on the outside. Just like order of operation, you treat it as like a parenthesis. You want to simplify everything inside the parenthesis before you start working on outside the parenthesis. So hopefully this makes sense. Let me know if you have any other concerns. This is a bit of a lengthy explanation, but I hope this addresses any issues you were having.